So I am going to bring in our next guest. And this is a switch now from cognitive services, and we're going to go into getting real-time insights from your serverless solution. And to present this is, I'm going to say this wrong, Edward Kielholtz. And I'm going to bring you in, Edward. Did I butcher your name? Tell me, did I butcher it?
No, you didn't. It's actually it originates from Germany. So I'm from Holland. So and it's a German name. So yeah, I can imagine it's hard to pronounce for you, but it's
I
actually
tried.
it's Kailos. But yeah, that's
Oh, you
German.
see, I did butcher it.
Oh, no,
Kyle
you
Hutt.
didn't. No, you didn't.
So you, as you said, you're coming in from the Netherlands today, and oh, you're going to be working with one of my favorite things, SignalR. I love working with SignalR. So I just want to say to everyone watching, oh, and we just had a raid as well on Twitch from Emma Dashi. Thank you so much. If you have questions for any of our speakers, and particularly Edward right now, once he gets going, obviously, please tag Edward and .NETConf hashtag on Twitter so we can have some questions at the end. And without further ado, I'm going to hand over to you, Edward, to tell us all about getting more insights with serverless solutions. So over to you. Thank you.
Thank you. Well, the thing is basically, yeah, getting real-time insights in your serverless solution. And I first want to introduce this session, why I came up with doing this session. And that's because I work as a consultant. And at one of my customers, they had this nice file import process, and it was running on an Azure function. It was a daily process, so they had a file and they uploaded that to an Azure function, and the Azure function was processing the file and then finally store the data in a SQL Server database. But over time, the import file grew larger and larger and larger each and every day, and they finally ran into timeouts. So that was a problem for them, and I investigated that, and I saw that they had this one single function that accepted the file, parsed it, validated the data inside the file, and then checked in the database if the data is already present, whether an update or an insert was needed, and then actually performed that data. And they didn't have any clue what was going on the server. They just either gotten timeout or an error. Yeah, something went wrong there. Sorry, we couldn't import your data. And in some cases, they received a success message. So I wanted to change this in two ways, because at first I think that the architecture of this is suboptimal. So there are some possible changes there. And the fact that you didn't have any insight in what was going on your server, I wanted to change that and give some feedback from the server what's going on in your import process, and show that somehow on a website or something. And that's where SignalR kicks in, and it's really a really powerful service. So that's what we're going to do today. First, an introduction of myself. I'm Edward Kells. I work as a solution architect in the Netherlands at a company called 4.net. Please follow me on Twitter, because that makes me feel good. And yeah, the rest is here. So we're talking about an import process. So we want to import a file from somewhere to the cloud. And we first need to identify what we think is important for an import process. So first, you want the import process to be resilient. If something goes wrong, you want the process to be able to continue where it left off, or where it crashed, if you want. And you want control over the process, meaning that if something went wrong, or for example, if your data is invalid and you got a validation message, you want to be able to change the data and then represent the data to the server so it can reprocess it and be able to continue. Also, performance may be important. Sometimes you don't care about performance. You just deliver the file and you don't have to wait for it. You go and process that, and when you're done, just notify me and I'm good with that. But sometimes you're actually waiting for the file. So you want it to be fast and you want the process to be completed as soon as possible. And then last but not least, you want insight in what's going on. So you want some feedback from the server. Hey, I accepted the file. I see that there's, I don't know, X entries to be imported. I'm now validating stuff. Hey, this entry is not valid, and this entry is. I'm going to persist it for you. And you want this information to be sent back to your user, providing some feedback of what's going on your server. So to do this, I created a couple of Azure Functions, and I used an event mechanism for this. But you have to know what an Azure Function is. So for just a brief introduction, in case you're not familiar with Azure Functions, well, it's already in the name. An Azure Function is basically a short piece of code, basically a function. And a function is requires a trigger. It needs to be triggered by a system. And a function can have input and output bindings, which you can use to pull data into your function or write data to an external system from your function. And there's a couple of things that are important to keep in mind when you start writing Azure Functions. First, you got to avoid long-running functions because else you will run into timeouts. You can set these timeouts, but I believe they're limited to 20 minutes. So if you run for longer than 20 minutes, you have a problem. You can go to durable functions, which allow you to run longer, but that's just a total different approach for now. Your functions are stateless, so make sure that you don't assume information is already there. When you want to pick up where a previous function left off, you have to use persistence somewhere. Yeah, and the last one is also, I'd like to address that one, avoid large libraries, because large libraries prevent your Azure Function from starting up quickly. So for example, if you use a SQL Server and you always use Entity Framework, which Entity Framework 5 just came out, but I don't know about the size of that one, but for the old Entity Framework, it was about 6 megabytes. So if you're going to use that library, keep in mind that you're also claiming 6 megabytes in memory, and it takes some extra time for your function to fire. And then there's this SignalR framework, and SignalR has been around for quite some time. I believe the first release was somewhere February 2013. And what we're used to do is you used to create a hub somewhere inside your ASP.NET project, and you define some functions that you want to call on the client side, and that will generate a JavaScript for you, which you could include on your website, and that allows you to actually set up communication between the client and the server. Now, one step back, if you're not familiar with SignalR, SignalR is a real-time framework that allows you to communicate with the server, but it also allows you to create a connection to the server and allow the server to initiate communication back to the client. So that gives you the possibility to give some real-time information from the server to the client without having the client to initiate the connection. So it's bi-directional communication. And to do that, SignalR uses a couple of connection mechanisms, and the best mechanism possible are WebSockets, but there are 3 different fallback scenarios in case WebSockets are not supported for either your browser or the server. We're using SignalR in a serverless environment, and that means that the entire hub scenario that I just told you about is gone. You don't have to create a hub or something. You just create a connection to your Azure Function, and you just create a connection to your SignalR service, and you can invoke functions on the client, and when these functions are handled client side, they will actually execute some code on the client side, which is really powerful. So what you need to do is you need to provision a SignalR service on the Azure portal. And in this case, we're going to use the SignalR from a serverless environment. So what you need to do is go to the properties of your SignalR service and set the server mode to serverless. That actually allows you to use the service from within a serverless environment. And then last but not least, since we're connecting using JavaScript in this example, you need to make sure that you check and configure your core settings, because else the connection will be blocked. So I told you about this import process at the client. They had one big Azure function doing all the work, and that's not what, in my opinion, is the best practice for an Azure function, because you really have to separate concerns and make sure that a function has only one responsibility and then move on. So I came up with a total different architecture, which is a little bit more complicated. And it starts off with a storage account. And in this case, it's blob storage, because I don't think that uploading a file directly to a web service, an HTTP endpoint, is a good idea. You can use the valet key pattern, for example, to upload the file directly to storage, and then have an Azure function trigger on that storage, so that when the entire process is done and the file arrived on storage, you can then execute a function and process that file. So that's what we're going to do. Wait for the file to arrive on storage and then parse it. And either, no, not either. And when it's parsing the file, it will see that there's a couple of entries that we need to import. And once that is done, we know, for example, that the file contains, let's say, 1,000 entries. We can already send a status message. Hey, I received the file and I see that you want to import 1,000 entries. And you can then report that back to the user. So I added a new function. This is these purple blocks are queues, by the way. And in my previous examples, I used storage queues, but these are I updated this my demo project, so they're now service bus queues. And I created a new function that was actually triggered by that service bus queue, and it sends a message to SignalR, which allows you to send a message to the browser. So at this time, we know that an import is started with, let's say, 1,000 entries. So I can show something to the user. And for the validation queue, each and every single entry will end up as a message on the validation queue. So that allows me to create an Azure function that will validate data and then store stuff in persistence. The advantage of this is that when the larger my import file is, the more messages arrive on my validation queue, and that allows my Azure function that validates my data to scale, and that speeds up the process dramatically. Now, when this function validates the data and thinks the data is correct, it will then store the same message again on a different queue. That's called persistence. And yet another function will be triggered by that message and then finally store data in persistence. But unfortunately, not everything goes as we would like it to go. So, for example, if you present a file that's unknown, in this case, I'm going to import a file in a JSON format. But let's say that I present a file of an image format, for example, then this parse function will fail. So we also need something to handle errors. So in case this happens, I send a message to an error queue, which is also handled by a function, and I can update the status of the import. And in this case, sorry, but the import failed. And I can then report that back to the user, again, using SignalR. And finally, in case an entry goes wrong, for example, a single entry in my validation process is, for example, invalid because of reason X, I can report that to the error queue as well and then store it. So I enable the user to correct the data and represent it to the import process. So that's also going on the validation function and the persistence function as well. They allow me to report errors back to the error queue and then also send that to the user. So enough talking, let's go for a demo. I have Visual Studio open right here. We will dig into some code right in a while. As you saw on my profile briefly, that I have a little affinity with Angular. So I created an Angular front end, and this Angular front end connects to my SignalR service in Azure. And it's now just waiting for files to arrive on storage. So as you may see here, I've got this blob container called import right here. And if I open that up and start uploading files to that blob container, you will see that on the server side, my Azure Functions will actually start running and import the file. So let me upload a file, then go to the browser. And yeah, there it is. The file's uploaded. My Azure Function already processed the file, and it saw that there's 1,000 entries, and it will just start importing and give me feedback about the progress. So 1% is done. 8 entries, or now 28 entries, are already imported, and now 49 are filled for reason X. And also, I can also add more files sequentially. So, this demo, more imports are running simultaneously. And as you may have seen, I also uploaded an image file, which should fail. And yeah, there's an error. The file could not be processed. No import was done. And all the other imports are running in the background. Let me check. 5 minutes left. So okay, let's have it running in the background for a while and see what happens, and dig into the code. So this is basically the Azure function triggered by my blob storage. You can see that as a blob trigger, and it's looking for blobs, which is a binary large object, by the way, for blobs in the import container. And I use this name in braces, so I can also inject that into my function and use that later on. For example, using this log message. A file with this certain name was arrived. I'm now going to process it. Now, I think that one step is important here, and that's this correlation ID. right here. For each import, I generate a new correlation ID, and from then on, each and every message going back and forth between the queues relate to this very correlation ID, so that I can find everything going on my entire import process for a specific file, depending on this correlation ID. So if I know this correlation ID, I can then use this correlation ID in a search, for example, in Application Insights, and see exactly what happened during my import. You can see here, this is where I parse the file, and you can see that I have a list of entries here. So at this point, I already know the amount of entries in my file that I need to import. And you can see that that I immediately sent a status update with the amount of entries in my import, which is actually going to a different queue. So going back up a little bit, here are my service bus output bindings. One is for the validation. So when a new entry is found, it goes to the validation queue. I want to update the status. And this is actually a nifty trick, a status loop that allows me to check whether the import process is still going on. And while this import is going on, it will keep on reporting status updates through SignalR. So going a step further, this validation message, I have one validation rule, and that's when I'm actually importing users, by the way. And if a user is older than 80, I'm not going to allow it. I don't know why, but I just needed a validation rule. It's not that I hate elderly people or something. Yeah, it's just for demo purposes. And this one has two output bindings. One is to persistence. So if the message is validated correctly, then I can pass the message through to the persistence queue. And in any other case, I will store it in the error queue. And then persistence, yeah, basically more of the same. It's just catches the message, and in this case, I store the data in the table storage. And when that fails, I again send a message to the error queue. Hey, I tried to store this, but it failed for some reason. So here's an error. And when I zoom into this part, you see that I've got a couple of tables. One is the error, one is for my status. This is again the nifty trick for the status update and the actual data being imported. So if I now go to the users table, you can see that there's actually data imported. For the SignalR part, let's dig into that. Is this one. Connecting to SignalR is actually fairly easy, because SignalR sits in Azure as a separate service. 1 minute left. As a separate service, and from your client, you connect to your Azure function, and your Azure function does nothing more or less than redirect that request to your SignalR service. So that basically means that from then on, your client will be actually connected to your SignalR service instead of your Azure function. But this is a nice way to also validate whether this client is actually allowed to connect to SignalR, even though the SignalR service has some authentication capabilities itself. But yeah, so I can see that all my imports are done. They're gone, except for the file that actually failed. So I assume that this import was successful. So yeah, everyone's happy. Thank you for joining. I hope you like my story. As I told you, this is a demo project on my GitHub. You can follow the link on this slide. And again, if you want to reach out, my website is all the way down in the bottom. You can see my Twitter, LinkedIn. Yeah, feel free to connect, because yeah, like that. So Let's see if Leila's there. Yeah, she
I
is.
am. I'm here. Thank you so much for that, Edward. It was great to see you. We've had some questions, which is good. And I love it when people live code and it goes. So let's go and have a look at the tag board and see what questions we have. So I know we've got one right here. Let's bring this one up. So I wanted the best practice to convert an N-tier API to serverless API using Azure Functions. How can we use utility project used by all our APIs if we wanted to avoid loading the custom project DLLs, which has the utility methods in our function project?
Oh wow! I think this question is actually a good question, but a little bit outside the scope of this session, and I think it's a very hard one to answer just out of the blue. Yeah.
So we can come back to that one at another time then, or maybe asynchronously on Twitter. But thank you very much for the question. Now, I guess that there was a new post that came in here because I think this is going to be the quote of .NET Conf. It's not like I hate the elderly people or something.
Yeah. Awesome.
So
I needed a validation rule, but I want to include everyone. So that's also people older than 80. But I needed some validation rules so I could demonstrate failing imports.
So I think we had one question on YouTube, but I believe it has been answered. It was just, do durable functions support .NET 5 yet? And I believe it's work in progress at the moment. It was answered. But if you have questions for Edward, make sure you tweet at him, and I'm sure you'll be happy to answer them after this. So thank you so much for the demo. It's great to see code live. Also, Edward, do you want to share the GitHub repo on Twitter for that as well? Because I think it's always interesting. Yeah.
Yep, will do.
And with that, I just want to say thank you very much for coming and speaking to us today.
One remark that my GitHub repo, this is actually a working demo, but as I mentioned, I just shifted all the queues from storage queues to service bus. So I have to update the documentation a little bit, but yeah. I will share the repository.
Yeah. Oh, I did. Now you've said that, I remember there was another question, and it was from Mr. P. Morris. What is your strategy for dealing with service bus dead letters? Is that in scope, do you think?
Yeah, it might be. Because you have this retry of a message, and for example, if a message ends up on the validation queue, and your validation process fails for some reason, it will retry for a couple of times, and when it keeps on failing, the sun is shining. I have a lot of backlighters.
Don't you worry.
And if you have a lot of failing messages, it will end up on the dead letter queue. So you have to do something about it, and you have to monitor the dead letter queue. So what I do by default is create alerts in Application Insights. So I'm sure that I'm aware when messages arrive or end up in the dead letter queue. But yeah, I think that for a general answer on how to handle messages on the dead letter queue, it really depends on the situation. But it's good to have a strategy to at least be aware of messages arriving on the dead letter queue.
Yeah. Great. Well, thank you so much for joining us.
Yeah, thank you too.
Yeah, and enjoy the rest of your day and .NET Conf. So take care. Cheerio. Bye.